Now there is the next term which is very important, half-life. Now what is meant by half-life? So suppose if you have 20 atoms at time t equal to 0, for example, and after certain time, let us say capital T, number of atoms becomes 10, right? So what does this means? 10 is half of the 20, that means 10 left and 10 are already decayed, right? So if I say that time is capital T, I call it as half life, right? Half life period I call it. What is meant by half life period? It is the time during which the half of the atoms got decayed, right? Is as simple as that. Okay, so half life is the time taken for the number of active nuclei to decay into half of the original number n naught. That means we can say the number n is equal to n naught by 2 now, right? With this explanation. Now, mathematically, it is proved that this value is independent of original number n naught. How? We will see that. Okay. Now, here is the graph. You can see concentration of number of nuclei with the time, right? So you can see this graph is the exponential in nature because we have already derived that expression, the relation between number of nuclei present at an instant and the time. So it is exponential curve. So we have got this graph, right, with that experimental result. So now let us see how we are going to derive the expression for half-life. So now what we have did, we already have the expression n is equal to n naught e to the power minus lambda t, right? We have put n is equal to n naught by 2 because we need to calculate the time at which the number of nuclei present at that instant becomes half of the original nuclei, right? So n naught by 2, and time becomes t dash. This t dash is nothing but half-life time or half-life period. So when we have calculated this thing, you can see we got this result, log to the base e2 lambda t dash, and we know that log to the base e of 2 is 0.693, right? So we get that half-life period as 0.693 by lambda. So this is the final expression for half-life period, 0.693 by lambda. Right. So from this expression you can see that this capital T, that means half-life period, is independent of number of nuclei present at time t equal to 0. It is just dependent on this decay constant lambda. One more relation you need to have is number of nuclei present at any instant upon original number of nuclei n naught is equal to 1 by 2 to the power small t by capital T, where capital T is what we can say half-life period. Also you can replace this number of nuclei with activity, right? So activity A by A naught is equal to 1 by 2 to the power T by capital T. Entrance point of view, the shortcuts are very much important, right? We will also discuss a numerical on the basis of this formula too. So this formula need to be learned. Okay. Also you can replace this n with n2 and n naught with n1, right? So if you have certain time interval between 2 to 3 seconds, if you are aware with this capital T half-life period, there you can just replace these things. Okay, we will have the numerical, so we'll discuss this thing afterwards. So you can remember these two formulas, right? One is in the form of number of nuclei and second is in the form of activity.